equations of lines. So in this discussion, we will discuss how to obtain equations of lines, and we will basically focus on how to apply this idea to business applications. Equation of a line is a linear function, and it is symbolically represented as f of x equal mx plus b, or simply we can even say y equal mx plus b. So this format or this form is called point slope form. We can also represent this equation as a line graph where m represents slope and 0 be the ordered pair that represent the y-intercept. So let us understand this representation on a graphical setup here. The slope of this line is m, which is change in y over change in x, and also the y-intercept is 0 and b. Now, of course, if the slope is negative, the line will be a decreasing line. Sometime we will express this relationship y equal mx plus b as a linear combination of two variables x and y, such as ax plus by plus c equals 0. If this happens, we can always solve for y here and write this equation in this format. Now let's say, for example, I have an equation like 3x plus 2y plus 7 equals 0. You can recognize 3 is our a, and 2 is our b, and 7 is our c. Now if I try to solve for solve for y, we can move both 3x and 7 to the other side of the equation by subtracting both from both sides, and we divide all of these terms by 2, and we will obtain y equal negative 3 over 2x plus minus 7 over 2. Now you notice our slope here is negative 3 over 2, and my y-intercept is negative 7 over 2. Now let's look at some examples or business-related examples to illustrate how we can apply this linear equation of linear models or equation of line to represent a situation in business. So let's think about, or let me consider my first example. Now it is a family example where we will try to connect or write a linear equation connecting the phone bill or the cost of phone bill and the additional minutes someone makes. Let's consider phone bills for 2 months. So let me call month 1. The cost of the phone bill or the cost was $75. In that particular month, the person made 100 minutes of additional minutes. Now most of us have phone plans where they have a basic plan charge plus for any additional minutes you paid additional amount of money. Now let's consider the second month. The same person paid $85 as phone bill, and he made 150 minutes of additional minutes. Now when you get these two numbers, we can always interpret this as two ordered pairs. First of all, we have to recognize which is our dependent variable and which is our independent variable. In our situation, the phone bill depends on the additional minutes. So in other words, if you make more additional more minutes of calls, you may have to pay more money. So in that respect, X is our independent variable. I mean, the additional minutes is our independent variable, and the cost becomes the dependent variable. If we interpret this two informations, or 2 months, month 1 and month 2, as two ordered pairs, we will have the first month, we will have 100 minutes and $75. And for the second month, we will have 150 minutes and $85. Since we have converted this information as two ordered pairs, we can now create the required equation connecting these two numbers. And again, we are assuming the relationship between the cost of the phone bill and the additional minute is linear relationship. Now since we got two ordered pairs, we can easily find the slope, which is m, change in y, which is 85 minus 75 over 150 minus 100, same as $10 over 50 minutes. So it's about 0.2. So that's our slope. Once we obtain the slope, we can write the expected equation, which is y equal mx plus b, using two different ways. So let me say method 1. Since we know the slope is 0.2, which is m, and we are also looking for an equation y equal mx plus b, where m is the slope, b is the y-intercept, we could substitute 0.2 as m, and we will have a situation at this point as y equal 0.2x plus b. Now our task is only to find the b. To find b, we could use one of those ordered pairs, either 175 or 150 and 85. Now let's say if I use 175 into this equation, substituting 75 for the y and 100 for the x, I'll be able to obtain the b here. B equals 55, because 0.2 times 100 is 20. So if you subtract 20 from both sides, I get b is 55. So we will be able to obtain the equation, the required equation, which is y equal 0.2x plus 55. Now this is one way, or let me call it method 2. Now if you know a format called point slope form, which is y minus y1 equal m times x minus x1, and as usual m represents the slope, and x1 y1 is any ordered pair on that line. Now in our situation we do have two ordered pairs, so I'm going to be again using this previous ordered pair, which is 100 and 75. If I use two ordered pairs, substitute x1 is 100, y1 is 75, I should be able to get y equal y minus 75 equals 0.2, which is our slope, times x minus 100 will yield 0.2x plus 0.2x minus 20. Then then if you add 75 both sides, we'll obtain the same equation, which is 0.02x plus 55. Now both ways we could reach the same answer. Now one can easily follow any of these methods. Hereafter I will be using method 1 throughout our discussion, because in this method we don't really need to recognize or memorize this point slope form here. Before we go further, let's understand what this 0.2 and 55 represent in these particular examples. Of course, 0.2 is the change in the y, which is our cost, for an additional x, which is the dollar amount, the additional minutes every minute. So in other words, the 0.2 represent the cost of the phone bill per additional minute. And how about this 55, which is our y-intercept? Now obviously, if I plug x is 0, the value of the y is the y-intercept. So in our case, x is additional minutes. So even if you did not make any payment, you may have to pay $55 as the phone bill. So that means this is our plan cost, or the cost of our plan. Let's consider our second example. We are talking about a situation where a business bought a car for $20,000, and after 5 years their book value, or the trade-in value, is expected to be $7,000. So in other words, over the time 5 years, the car depreciated to $7,000. Now in this particular case, we are assuming the car is depreciated linearly. In other words, the depreciation is equal for every year after the car is being purchased. Now, first of all, as we did before, we could interpret this as two ordered pairs. So when the car was bought, the age of the car is 0. So this is how old the car was with the company, and at that time the price was $20,000. So the first ordered pair is 0 and 20,000. And of course we know the value of the car, which is the y coordinate, depends on how many years the business owned that vehicle or the car. Now the second situation is, after 5 years the car was only worth $7,000. So we now got two ordered pairs. As we did before, immediately we could be able to find the slope, which is m. Let's say this is 7,000 minus 20,000 is change in y over change in x, which is 5 minus 0, give me negative 13,000. Over 5, which is negative 26,000. In other words, every year the car was depreciated by $26,000. Now once we get the y-intercept, I could write the equation for the value of the car y equal negative 26,000 times the number of years plus the weight constant b. As we did before, we could use any of these ordered pair to write the equation. Now if someone can realize this x is 0 and y is 20,000 is the y-intercept, if someone realizes that, then we can simply write the equation as y equal negative 26 plus 20,000. Now if you look at this equation, and if you like to interpret these two numbers, which is the slope and the y-intercept, obviously when there was the value of the car when the time is 0 is $20,000 as we know before, and for every additional x, meaning for every additional years of the life of the vehicle, the value is depreciated by $26,000. So let's consider another example. Let me call that as example 3, talking about a vendor selling some merchandise, and if we set the price to be $100 per unit, he was able to sell 5,000 units. Now he also found out if he increased the price to, let's say, $120, and he was able to sell only 3,000 units. Now let's also assume that the relationship between the price and the quantity is linear. In other words, there is a linear relationship exists between the price and the quantity. First of all, we have to know which depends on what. Obviously, the merchant set the price and let the market to absorb number of units. So in that perspective, the price becomes x coordinate and the quantity becomes the y coordinate. Of course, someone can use P and Q if he likes. I just continue to use x and y here, but someone can use x as the price, which is P, and y as the quantity. Now again, in this situation, we can interpret this as two ordered pairs. Now the first ordered pair is $100 and units is 5,000, and second one is 120 units and 3,000 units. Now using this information, we could calculate m, which is our slope, 3,000 minus 5,000 divided by 120 minus 100, which is negative 2,000 over 20, which is negative 100. Now once we find the slope, if we follow the same steps like the one that we did before, y equal mx plus b, and we do know the m, so we could write y equal negative 100 x plus b, and we can use any of those ordered pairs. This time I'm going to use the second ordered pair, which is 120 and 3000. So if I use that, I'll have 3000 equals negative 100 times 120 plus the b. So this will be negative 12,000 plus b. So the b is in fact equals 15,000. So our equation will become y equal negative 100x plus 15,000. So what are these two numbers represent? Negative 100 and 15,000. Now obviously the negative 100 tells for every additional dollar he increases the price, he will lose 100 units of sales. And the 1500 represent, even if the price is 0, market will absorb about 15,000 units of his product. So once we created this model, one should be able to interpret the meaning of the slope and the y-intercept. So let's look at another example. This involved a little bit of a calculus based. So the question is, find the equation of tangent line of y equal 3x squared plus 2x plus 1 at x equals 1. As we said before, to write an equation of any line, we need at least slope and an ordered pair. Now the first question is, how do I find the slope of the tangent line at x is 1? To find slope, we need to find the derivative of y, which I'm calling as y prime, which is 6x plus 2. Then if I evaluate this at x is 1, our slope for the tangent line will become 6 times 1 plus 2, which is 8. So we got the slope, which is 8. Once we got the slope, we need at least an ordered pair. To find the ordered pair, if we substitute x is 1 into the given equation, we'll have 3 times 1 squared plus 2 times 1 plus 1, which is 6. So that means we have the ordered pair, which is 1 and 6. So like the way that we did previously, we do have, since we have slope and y-intercept, I could first write y equal 8x plus b, and substituting x is 6, x is 1 and y is 6, we will have 6 equals 8 times 1 plus b, so b becomes negative 2. So finally we get y equal 8x minus 2. So we are not going to elaborate too much on to this kind of a question here. However, if you know the slope of a tangent line, or any line for that matter, and another ordered pair, we can always write the equation of the line that we are looking for. Now let's look at another example. Let me call that as example 5. Now we wanted to talk about a company that buys and sells tires. They buy the tires for $30 a piece, and they'll be, according to their research, they will be able to sell 960 tires if the price of the tire is $50 per tire. They should be able to tell 1,080 tires if the price is set to $40 per tire. Now, using this information, can we find, is it possible for us to find the cost, revenue, or profit function for this business? So for our discussion, I'm going to call price to be small p, and the quantity to be small q. First of all, as the way it is presented, we can talk about the demand of his product, his merchandise, price and quantity, as two ordered pairs. The first one is 50 tires, $50. He'll be able to sell 960 tires, and also at $40 per tire, he'll be able to sell 1,080 tires. So using this information, we should be able to find the slope, which is m, let me call it m, which is 1,080 minus 960 divided by 40 minus 50. It will work out to be negative 12, I guess. So we got the slope, which is m, negative 12. So we could express the quantity q as negative 12 times price plus a constant b. Now, as we said before, to find the constant b, we could use either one of those points. So I'm going to be using the first point, which is 50 for the price and 960 for the quantity. So I'll have 960 equals negative 12 times 50 plus b, and that will be then 600 plus b. So from here we could find b as 1560. So we will have the equation connecting the price and quantity. Q equals negative 12p plus 1560. In other words, for every dollar increase, he will lose the sale of 12 tires. So, by the way, sometimes this kind of equation is called demand equation, because this expresses the demand and how his product is being demanded by the customers. Now, so to find the cost function, we need to know the cost price. So let me talk about the cost side of this cost for this business. The cost here, they don't have any fixed cost expressed. If you do have fixed cost, you need to add that amount to the cost of buying the units. Now, the only cost that they have is just buying their product, or which is tires. So let me say 0% cost is basically the price and the cost price per unit times the quantity. So this is same as, we know the cost price of the unit, which is $30. So 30 times the quantity, which is Q. Now we do have an expression that connects the quantity and the price. So this is same as 30 times negative 12p plus 1560. So if you distribute 30 to all of those to that expression, we'll have negative 360p plus 468. So that's our cost function. Now we also need the revenue. I'm going to call that function as R equals price times the quantity. Here the price is the selling price. As we know, selling price is P. Now the Q is again given as an expression here, negative 12p plus 1560. So that will come out to be negative 12p squared plus 1560p. Now from here, if we like to find the profit function, of course we do know profit equals revenue minus the cost. So that will work out to be negative 12p squared plus 1560p minus the cost function, which is negative 360p plus 46,800, and obviously this will come out to be negative 12p squared plus 1920p. So this is the profit function. Once we obtain profit function, we could talk about the maximum profit you can obtain from the sale, or what's the optimal level of production or number of units you need to sell to maximize profit, and so on. That's outside the scope of our discussion. However, this expression here will tell you the profit is a profit function, so we could always find out what could be the profit if he sells a certain amount of tires per day or so. To complete our to conclude our discussion, if somebody can use graphing materials or other mathematical ideas, one can learn that they had to sell at $80 per tire, and they will be able to sell 600 tires, and they will make a profit of $30,000 to maximize their profit. So the profit is maximized when they sell $80 per tire, and they will be able to sell 600 tires, and they will make a profit of $30,000. Now, however, all these examples are illustrations of using linear equations in business applications. Hope this will give a good idea of how to use linear functions or linear equations in business applications. And the basic task is to express the given data as two ordered pairs or an ordered pair and a slope, so that will make us to find a linear function connecting those variables.